Hey everyone, this is Bhargav Suthar, and today we will learn what is a lattice and what is a sublattice. So in this session we will discuss some more examples of a lattice and also one or two examples of a sublattice. So first let us recall what is a lattice. So a lattice, it is a poset A less than or equals to, in which every subset of A has a least upper bound, that means LUB as well as the GLB. Now what is a lattice operators? Let us recall. So in lattice, LUB of A and B, it is denoted by this symbol A or B, and we can say it is known as this A join B. And in same manner, GLB of A and B, it is denoted by this A and B, and it is known as A meet B. Now we already know all this. Okay. Now let us discuss example. So the question is, determine whether the following Hasse diagram represent lattice or not. Now see, in previous session we already discussed 2 or 3 examples of a lattice. Okay, and it was a lattice. Now in this example, it won't be a lattice. Fine, I'm giving you the answer, it won't be a lattice. So this is the Hasse diagram. Fine. So first we'll create a LUB table and as well as GLB table. So in the table, first, how many points are there? A, B, C. There are 6 points. So in column, just write A, B, C, D, E and F. In same manner, in row, write A, B, C, D, E, F. Now it is the least upper bound. So what will be the least upper bound? The same point, that is A. Now A and B. So least upper bound of A and B. So it will be C. Now least upper bound of A and C. So least upper bound of A and C, that will be C. Now A and D. So A and D. So it will be D. Then A and E, it will be E, and A and F, it will be F. Fine. Now second, for B. Okay, now B and A. In A and B it was C, so here it will be C. Now B and B, as it is the same point, so it will be B. Now B and C. Okay, so it will be C. Then this B and D, it will be D. Now B and E, this B and E, it will be E. And B and F, so it will be F. Then C. Now for C and A, what was in A and C? It was C, so here it will be C. Now for C and B, what was in B and C? It was C, so here it will be C. And then C and C, as it is the same point, so it will be C. Now for C and D, it is D. Now C and E, the C and E, so E. Then C and F, so it will be F. Okay. Now for D, now D and A, in A and D, it was D, so it will be D. Now D and B, in BD it was D, so D. Now D and C, in CD it was D, so it will be D. And D and D, as it is the same point, so it will be D. Now D and E, this D and E, so E. And last D and F, this D and F, it will be F. Fine. Now E, the pair E. Now E and A, see E and A, so it will be E. E and B, so E and B, it will be E. E and C, it will be E. E and D, it will be E. E and E, it will be E. Now see, E and F. Now E and F and the least upper bound. Now for E and F, as you can see that there is no upper bound, so there won't be any least upper bound, so that means it is 5. So we will just put dash over here. Okay. Now F, for F and A, so all will be F. Okay, so F, then F, then F, then F, then F, and F and E, so it will be dash, and last F and F, it will be F. So as you can see that in LUB table there is one pair in which they don't have LUB. Fine. Now same graph, and now we will create a GLB table, that means greatest lower bound. So in the table, this is the GLB symbol. Now A, B, C, D, E, F. Okay. So in column A, B, C, D, E, F. Now in same manner in row. Now you can see that this A and A, so it will be A as it is the same point. Now A and B, then its greatest lower bound. Now you can see that A and B does not have a lower bound. Why? Now you can see that this A and B does not have a lower bound, so it won't have the greatest lower bound. So that means this pair does not have GLB, so we'll put just dash. Now A and C, so it will be A. Then A and D, now A and D, so it will be A. Now A and E, so it will be A. And A and F, it will be A. Fine. Now B. Now A, B and A. In A, B it was dash. So same manner, this B, it will be dash. Now B and B, as it is the same point, it will be B. Now B and C, this B and C, and greatest lower bound, so B. Now B and D, it will be B again. B and D, it will be B again, and last also it will be B again. Now C, C and A. In A and C it was A, so here it will be A. Now C and B, so in BC it was B, so here it will be B. Now CC, it is the same point, so C. Now C and D, so C and D, it will be C. C and E, it will be C. C and F, it will be C. Then D and A, so in A and D it was A, so it will be A. Then DB, in BD it was B, so B. Then DC, in CD it was C, so C. And DD, it is the same point, so D. Okay, now D and E, this D and D, so it will be D. And D and F, so it will be D. Fine. Now E and A, this E and A, so A. So except see, here it is the upper bound. Fine. So for E and any pair, so this will be the answer. This A, B, C, D, E, and now E and F. What will the greatest lower bound? This D. Fine. Now for F, now in same manner, A, B, C, D, and for E, the answer will be D, and last for F, it will be F. Okay, so here you can see that there is no LUB of the pair F and D, and same manner there is no GLB for the pair this A and B. So as there doesn't all the pairs does not have GLB and LUB, so hence it is not a lattice. Now let us discuss what is a sublattice. So the definition, let L less than or equals to be a lattice. Now a non-empty subset S of L, it is called a sublattice of L if this A or B belongs to S and A and B belongs to S. That means it is one is joined and another is one is meet whenever this A belongs to S and B belongs to S. So let us discuss in example. Consider the lattice L and determine whether or not each of the following is a sublattice of L or not. See, we have four sets L1, L2, L3 and L4, and the Hasse diagram is given. Fine. So we'll one by one check whether it is a lattice or not, sublattice or not. Now a subset, it is a sublattice if it is closed under this OR and AND. That means it has LUB and GLB. Fine. So the first subset L, A, B, M. So where is L, A, B and M? Fine. So the subset L1, it is not a sublattice. Why? See, for sublattice, consider this set L, A, B and M. So its LUB and GLB has to belong in the same set. That means in the L1. Fine. So just consider L and A. So LA, what is the GLB and LUB of L and A? So one is L and another is A. So can you find a pair in which the GLB and LUB does not belongs to L1? So is there any pair? So you can see that what is where is A and B? So A and B. So A and B, it's LUB, least upper bound, that is C, but C does not belongs to the given set L1. That means it is not a sublattice. So for sublattice, it has to be closed under LUB and GLB. So L1 is not a sublattice. Now for L2. Now for L2 and L3 we will consider, we will discuss only one. So L, A, E and M. So L, A, this E and M. So E and M, what is the GLB and LUB? That is M and E. So they are in the set. Now L and A. So A and L. So they are also in the set. Now for A and M or L and E, you can check for any pairs. So the LUB and GLB belongs to the same set L2. Fine. And in same manner L3 will be a sublattice. Now for L4, just give me one pair in which LUB or GLB does not belong to the same set. So the pair is C and D. Now C and D. So you can see that the C and D, what will the greatest lower bound? The greatest lower bound will be A. But A does not belong to the given set. So that means it is not a sublattice. So this is how you can find whether it is a sublattice or not. Thank you.